Here we have an example of performing a microoperation with the datapath that we just considered in the previous short lecture. The microoperation that we want to perform is shown here. R1 should be added to R2 and the result should be stored in R0. So our microoperation is going to use two source registers, basically R1 and R2. Then we will perform the addition operation and afterwards transferring the result of the addition into the destination register. The first step here is to determine what are our source registers. So R1 and R2 should be made available for our arithmetic logic unit. In order to do that, first we need to apply 0, 1 to A select. Okay, so where is A select? A select is over here. It is indeed the select line for our first multiplexer. So if we provide 0, 1 for A select, it means that the second input to the multiplexer will be selected and it will be passed to the output of the multiplexer. The second output here is R1. Therefore, at the output side of the multiplexer, we will have R1 available. Similarly, we do it for R2. It is the second indeed source for us. We can do it by providing proper value for B select. Since we want to have R2 over here, and that R2 is connected to the third input of our multiplexer, we need to provide 1, 0 to our B select line. Okay, with 1, 0 provided for B select, then R2 will be available at the output of the output line of the second multiplexer. And as a result, you can see here that at the input side of multiplexer B here, we will have R2 and R1 will travel directly to here. Then we want to pass this R2 through multiplexer B, mux B. Therefore, for MB select, we need to provide the value of 0. If we provide 0 to MB select, R2 will pass through multiplexer B, mux B, and therefore we will have R2 here. Okay, so we need to apply 0, 1 to A select, 1, 0 to B select, we place the content of R2 onto B data, and then we apply 0 to MB select, okay, multiplexer B, to place B data on bus B. So we have R2 here, R1 here. Now we need to perform the addition. In order to perform the addition, we need to provide proper value for our G select. The G select is used to determine which operation should be performed. We will see more details regarding this later. But for now, we can say that we need to apply 0, 0, 1, 0 to our G select, and then the operation of the addition will be performed, and the output that we get from it, G, will be equal to R1 plus R2. Okay, so we will have, if we apply 0, 0, 1, 0, we will have R1 plus R2 available here at the input side of mux F. So obviously, if you want to pass it for mux F for MF select, we need to apply 0. If we provide 0 to MF select, then R1 plus R2 will pass through it. We will have R1 plus R2 available here. We just need to pass it through mux D as well. As a result, for MD select, we also need to provide 0. If we do so, over here we will have R1 plus R2. So R1 plus R2 will be available on our D data. R1 plus R2 will be there. So let me just go through this as well. we apply 0 to MF select, and we applied 0 to MD select, and then we place the value of G onto bus D, and now we need to determine the destination register. Yeah, the destination register is R0. We need to select this in order to load the data into it. In order to select it for the destination select, we need to provide 0, 0. If we provide 0, 0 here we will have 1. That 1 will be here. If we provide load enable with 1, then here we will have 1. The load into R0 will be equal to 1, and then R1 plus R2 will be written into R0. Okay, so we apply 0, 0 to destination select as just explained, and then we apply 1 to load enable to force the load input to R0 to 1, so that R0 is loaded on the clock path. Whenever we have the rising edge of the clock, R0 will be loaded with the result of the addition, and the whole operation takes 1 clock cycle. Okay, so this is indeed an example of how the Datapath performs a given micro operation.